Welcome back to part 2 of Algebra 1, topic 28, Division Properties of Exponents. So today we're going to focus on the power of a quotient. This is going to be the top right section of your foldable once you fold it over. So power of a quotient, for any real numbers, a and b, where b does not equal 0, and any integer m, we have a divided by b, all raised to the m, equals a to the m divided by b to the m. So what I really just want to focus on right here is where b does not equal 0. That's because our b is in our denominator. And here, so b cannot equal 0 because we cannot divide by 0. Think about that when you have your slopes, and if you ever have a 0 in the denominator, that slope is undefined. So we can't have that here. If you were to type it in your calculator, you would get an error message. So if we have a divided by b all raised to the m, basically what we're doing here is we are applying our exponent to every term, whether that be in the numerator and the denominator. So if we go with our example, we have 3p cubed divided by 7 all squared. So we're going to apply this squared to the 3, to the p variable, and also to 7. So if we want to rewrite this, we get 3 squared times p cubed raised to the second power, all divided by 7 squared. So see how I applied that to every single term. You see that squared 3 different times because there are 3 different terms here. Then what we want to do is we're going to simplify. So we know that 3 squared gives us 9. Now if we have p cubed raised to the second, again, when we have a power to a power, we're going to multiply. So 3 times 2 gets us p to the 6th, and then 7 squared is 49. Now if our coefficients here, if our 9 and then our 49, if these could simplify or reduce, here's where we would do so. Unfortunately, 9 does not go into 49 evenly, so we cannot simplify this. This is as far as it goes. Okay, let's do a few examples. So if you open up your flap on your foldable, these are the 4 examples that are underneath. So first example, 2a squared b divided by a, all raised to the third power. So what we're going to do first is, if we do not see an exponent, I'm going to write 1. And now we're going to apply the 3 to every term. So to the 2, to the a term, to the b term, and then to the a down here. So if I want to rewrite this, this is the same thing as 2 cubed times a squared to the third power times b cubed all over a cubed. Now we know that 2 cubed is 2 times 2 times 2, which is the same thing as 8. When we have a squared to the third power, power to a power, going to multiply. 2 times 3 is going to give us a to the 6th. And then we have b cubed all over a to the third. But we're not done yet because we have the same bases here. A to the 6th and a to the third power, or a cubed. So we can subtract our exponents. So if we have our 6 minus our 3, that gives us 8, a to the third power, b to the third power. And that is our answer. Now if we want to move on to our next problem, this is probably going to get a little bit messy, I apologize. We're going to read it first. 4p to the 4th, r to the 4th divided by 3p squared, r squared, all raised to the third power. So we're going to apply that cubed to every single term. Getting a little messy. And then we're going to rewrite it. So we're going to have 4 cubed, p to the 4th cubed, r to the 4th cubed, all over 3 cubed, p squared cubed, r squared cubed. So 4 cubed is 4 times 4 times 4, which is the same thing as 64. Now when we have a power raised to a power, we're going to multiply them. So we're going to do that for all of these, actually. So 4 times 3 gives us 12. So this is p to the 12th, r to the 4th to the 3rd, power to a power, also r to the 12th, divided by. Now 3 cubed is 3 times 3 times 3. So here what we're going to do is we're going to rewrite this as 27. P squared to the 3rd power is 2 times 3, so p to the 6th. Now r squared to the 3rd power is r to the 6th. And now we can reduce. So are there any numbers, if we just look at our coefficients first, that go into both 64 and 27? Unfortunately, they do not share any common factors, so we can't further reduce them. So we're just going to leave them there. I know you guys are so upset about that. But, oh, hold on. But wait, there's more. We have p to the 12th over p to the 6th. These have the same basis, so we can subtract our exponents. So 12 minus 6 gives us, let's do 64, p to the 6th. If we look at our r variable, we have that in the numerator and the denominator. 12 minus 6 gets us r to the 6th, and then that's just going to be all over 27. And that is our answer there. If we move on to number 4, we have 2r to the 5th w cubed over r to the 4th w cubed to the r raised to the 4th. So here what we're going to do, we don't see any numbers or variables that don't have an exponent. So we're just going to apply this. Okay, so we get 2 to the 4th, should write equals, r to the 5th to the 4th, w to the 3rd raised to the 4th, all over r to the 4th raised to the 4th, and w to the 3rd raised to the 4th. Then if we want to simplify it, 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. R to the 5th to the 4th, power to a power, so we're going to multiply these. R to the 20th, w to the 3rd raised to the 4th, w to the 12th, and then we have r to the 4th to the 4th, r to the 16th, w to the 3rd to the 4th, w to the 12th, and now we can simplify. So notice how we have the same base here, r and r. We can subtract our exponents, so we'll end up getting 16 r to the 20 minus 16, which is 4. And notice what we have here, w to the 12th over w to the 12th. It's the same thing, it reduces to 1. So we're technically done with our answer right here. And something I wanted to point out here is if you look in your problem, in the parentheses, if we think back to PEMDAS, we can already see that right here. W cubed over w cubed. That would cancel right there. So that can reduce your work in the beginning, but I wanted to show you guys the longer way. A, just for more practice, and B, in case you didn't catch it, you can find out later that it does cancel. And you will still get the same answer in the end. There you go. Oop, I'm sorry, last problem. We have 3r to the 6th and to the 3rd over 2r to the 5th n to the first, all raised to the 4th power. So we're going to apply our exponent. You all know the drill. To every single term. And we get 3 to the 4th, r to the 6th raised to the 4th, n cubed raised to the 4th, over 2 to the 4th times r to the 5th to the 4th times n to the 1st to the 4th. Now, some people also ask me, Miss Reed, could I simplify in my parentheses first before I even apply that outer exponent? Yes, you could. Technically, in number 3, we did that same thing where we reduced that w cubed over w cubed, that reduced to 1. You could do the same thing here with subtracting your exponents. If you have the same base, notice we have the same base for r and for n, or you could multiply it out. I'm going to show it the longer way so that students can see how it's kind of for more practice purposes. But if you start to feel comfortable and you are noticing these patterns and you're following our properties of exponents as well as our rules of PEMDAS, you can do that. You will get the same answer in the end. So what we get here is 3 to the 4th is 3 times 3, which is 9, times 3, which is 27, times 3 again, which is 81. So we get 81, r to the 6th to the 4th, same bases, power raised to a power, so to the 6 times 4, r to the 24th, n to the 3rd to the 4th, 3 times 4, n to the 12th, 2 to the 4th, which is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, r to the 5th to the 4th, so we have r to the 20th, and n to the 1st to the 4th, so n to the 4. Okay, now we can reduce. Are there any common numbers, any common factors between 81 and 16? Sadly, there are not. But we can look at our bases here. We have a base of r to the 24th divided by r to the 20th. 24 minus 20 would be 81, r to the 4th, n to the 12th over n to the 4th. If we have, since they have the same base, 12 minus 4, that would give us n to the 8th, and then that would all over be 16. And there you go, there is your answer. Thank you for watching, and that is part 2 of topic 28, division properties of exponents.